choir director must select a group of singers from among his 6 tenors and 8 basses. The only requirements are that the difference between the numbers of tenors and basses must be a multiple of 4. And the group must have at least one singer. Let n be the number of different groups that could be selected. What is the remainder when n is divided by 100? Okay. So 6 tenors, 8 basses. I guess there's not that many combinations because the difference has to be a multiple of 4. And the group must have at least one singer. So it doesn't say it has to have at least one singer from each of each type. Okay. So what this means is, let's say, okay, what we have to keep track of is the fact that, of course, if we choose one tenor, there are 6 ways to do that. So it's not talking about, it's not asking how many different combinations of tenors and basses could there be, although that will probably be an important part of the question. It's asking how many different overall combinations can there be. Okay, so the way I'm going to do this is by writing out the number of tenors and basses that are possible. So this could be 0, 4, 1, 5, 2, 6, 3, 7, or 4, 8. Right? Or 0, 8. Right? The difference has to be a multiple of 4. Or, so this is when there's more basses than tenors. What if there's more tenors than basses? We could have 4, 0, 5, 1, and 6, 2. Is that it for the number, just for the number of tenors and basses? I think that's probably it. Right, difference between these is always a multiple. Oh, I am missing 1, 1, 2, 2, up to 7. Sorry, we obviously can't do 7, 7. Up to 5, 5, and 6, 6. So we could have an equal number of tenors and basses. Okay. And then for each one of these pairs, then it's a simple combinatorial problem of how many ways the tenors can be chosen multiplied by how many ways the basses can be chosen. So how many cases are there in total here? Okay, let's do it like this. Assuming the tenors is less than the basses. Zero, 4, 1, 5, 2, 6, 3, 7, 4, 8, and 0, 8. So this, the total number of ways of choosing 0 tenors and 4 basses, is 1 times 8 choose 4. This is 6 times 8 choose 5. This is 6 choose 2 times 8 choose 6. 6 choose 3 times 8 choose 7. 6 choose 4 times 1. And this is, there's only one way to do this, right? Sorry, not 1, 1, simply 1. Now let's do it with bases less than tenors. Let's write this as t greater than b. So now I have 4, 0, 5, 1, and 6, 2. So here we have 6 choose 4 times 1, 6 choose 5 times 8 choose 1 is 8, and here 1 times 8 choose 2. And then when the number of tenors is equal to bases, we have 1, 1, 2, 2, up to 6, 6. So this is 6 choose 1, 8 choose 1, 6 choose 2, 8 choose 2, and so on up to 6 choose 6, and 8 choose 6. Okay, and we have to add all these numbers up and then find the remainder when divided by 100. Okay. A lot of these numbers might be multiples of 100, in which case we can throw them out. How do we find which of these numbers are multiples of 100? Probably anything. That'll be a multiple of 100, right? Because we have 8 factorial. There, we're not dividing out the 5 in 8 factorial. But are there sufficient multiples of 2? Well, it's not going to be, there's no way this number is odd, is it? But this number might not be a factor of 100. I think I might just have to write out a lot of these. Okay, let's make a little bit more room. I don't need these numbers anymore. So this is 8 factorial over 4 factorial, 4 factorial. How am I supposed to figure out this number divided by 100? This is 6 times 8 factorial over 5 factorial, 3 factorial. Eight choose 7 is 8. 6 choose 4. 6 factorial divided by 4 factorial, 2 factorial. What is this number for? Did I... Oh, right, it's because when there's 0 tenors and 8 bases, there's only one way to do that. Okay, let's write these out. 6 factorial divided by 4 factorial, 2 factorial. 6 choose 5 is 6, so this whole product is simply 48. And this is 8 factorial over 6 factorial, 2 factorial. Okay. And all of these ones, so this is again 48. 6 factorial over 4 factorial 2 factorial times 8 factorial over 2 factorial 6 factorial. Oh, but we're dividing by 100, so we don't need a single power of 5 in the numerator. We need 2 powers of 5 in the numerator to do that kind of nice cancellation. I'm not sure what's going to end up happening here. Like, I suspect maybe there's an easier, more straightforward way of doing this. 嗯。So, like that. Numerator, that comes a 2, 7 times 2 times 5. Hmm. Eight times 7 times 6. Five times 3 times 7 times 4. Yeah, how are we adding this up in any efficient way? Like, these numbers are not multiples of 100, so we can't just throw them out. Some of these numbers are repeating themselves, kind of, right? 6 choose 2 times 8 choose 2. That's the same as this. Eight choose 4 I've computed already. 8 choose 4 is 7 times 2 times 5. Wait, is it? 8 times 8, 7, 6, 5. 7, 6, 5. 6 turns into 2. Yeah, okay. 6 times 8 times 7. And this is 8 choose 6. 4 times 7. Huh. How many different numbers are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm not sure what there's no way I'm just meant to add these all up. Should I just group things in some way? Oh man. I mean, it's not going to be that bad to add them all up, is it? This is 70. I'm going to use a different color. 70. I'll leave the big one, 876, for later. This is let me see, 20 times 21. 420. 20 times 8, 160. 15, 1. 28, 48, 15, 48, 3547, 3547, that's 420. 5487, I'll save that for later. 35725, that's 70 times 15. 687, save that for later, that's 28. Okay, so I need 8 times 6 times 7. 48 times 7. 336. And this one, 20 times 56. Did I do this right? Hold on. Yeah. 20 times 56. 1120. Is that all of them? I think so. Well, we only care about the remainder after dividing by 100, right? So let's just keep the first. Any 3-digit number can be just thrown away. Well, you know, the digits can be canceled. So we've got 70, 36, 20, 60, 15, and 1. 15, 48, 28. And here, 48, 20, 20. Oh man, 15 times 70, I'll come back to that. 36, 28. $15 times 70. 1050, so that's 50. Okay. This gives 6, 80, 16, 58, 63, 60, 76, 40, 64, 50, okay, 86, 79. That goes over 100, so we're just left with 6. And wait, hold on. It goes over 100, but we got to be careful. 16. And 14. 86 plus 79. 16. Okay, well, hold on. 6 and 9 is 5. 8 plus 7. 15 is 16, so 65. This is 30. So I get 95. Now, this was a multiple choice question, and 95 is one of the options. So that's somewhat of a positive outlook, but there's a lot of places I could have made simple arithmetic mistakes because I was going so quickly. Maybe this isn't the best way to subdivide things by, it's the first thing that comes to mind, certainly. You know, how many tenors and how many bases can you possibly have? Write out all those combinations. Each of those combinations tells, then it's a problem of working out how many ways you can choose from the subgroups to make those, or subsets to make those combinations. But after that, the arithmetic was quite messy. I don't know if there's some kind of simplification I'm missing, like an identity or something like that. But after modding everything by 100 and adding up and continuously modding, I get 95. But yeah, there very well could be an arithmetic mistake here. If I have the wrong answer, I'll let you know. Thanks for watching.